Okay, so today we're going to begin a new chapter, chapter 4, and chapter 4 is mainly about logarithms and logarithmic equations, but there's some background information we need to go through in order to be able to understand some of the things that are happening in the future. In the first one, in 4.1, we're going to be talking a little bit more about functions and some properties of functions. Now, the mathematics behind this is not difficult. Your job is to memorize and know when you need to be able to use these certain features and be able to recognize features for what they are. Now, the first section we talk about are something called inverse functions, and you might remember or may not remember the word inverse. The word inverse is not really opposite. It really means that you're undoing. Okay? So if you have the inverse of something, then you're undoing it. For example, if you have the fraction 1 over 4, remember that that literally means 1 divided by 4. And so the inverse of 1 over 4 would be 4 over 1. You're just going to reverse it. Because if you took those two things and multiplied them together, you're going to get 1. So what happens is, and then multiplying by 1 would not do anything. So the inverse allows you to eliminate something and eliminate its effect on anything else. Okay? So keep that in mind as we go. And when we're talking about functions, we're going to have a functional notation f of x, right? Well, if you want the inverse, then they just put a little -1 by the f. Okay? This is read as the inverse of f of x, or the function f. Okay? So, anytime you see that little -1, think inverse. You're going to see the notation. Now, before we can start talking about inverses and how to find them, which again is mathematically nothing, but you've got to memorize the process, that we need to talk a little bit more about functions and some special types of functions. Okay, so let's go to our homework so that we can look at some functions. Remember, first of all, remember that we define a function where every x leads to some y, right? And it's not a function if an x leads to more than one y. Say we have 2, 3, 3, 4, 4, 5. Now this is a function because every x is leading to its own distinct y, right? Okay. It's not a function if we can have more than one value for each x. So say for example we had, oops, sorry about that. We have the function 2, 3, to -2, 4, 5. To see that in this case 2 is leading to 3 and 2 is also leading to -2, and that can't happen. What that's telling you is that you're getting a graph that opens something like this. Now remember, our test for function, we can look at the numbers to make sure that no x is leading to more than one y value, but we also used another test for function, and that was called the vertical line test. And now remember, be very careful, this is for a function, to determine if something is a function. If you can't draw more than one vertical line through the function, then indeed it is a function. So say for example we have this parabola. You can draw as many vertical lines as you want. You're never going to hit that thing more than one time. Okay? But the one we have down here that we know is not a function everywhere I draw a vertical line, it hits it more than once. Do you remember that? So the vertical line test is one of the tests that we use to determine if something is indeed a function. And we're going to use another kind of line test to test for the next type of function we're going to look at. Because what we're going to look at today is we're going to look at another kind of function, and these are one-to-one functions. Now if you think about one-to-one functions, sometimes written like that, then you're talking about a relationship where one number leads to one number. And if that's the case, it has to go both ways. So this time, we're not just talking about one x value leads to one y value. We're talking about the other way around. Okay? So say, for example, we had 3, 4, okay, 4, 5, 6, 4. Now this is indeed a function because 3 gives you one value, 4 gives you another value, 6 gives you another value. All right? But it is not a one-to-one function because if you look at it, here we have 4 and here we have another 4 in the y position. And so that's the difference for these special functions. Each y value has a distinct x value. So in other words, no values are repeated either in the x column or the y column. Okay? Now it's easier to see when they do the columns like this. So here it says the road mileage between city M and several selected cities is shown in the table. If we consider this as a function that pairs each city with a distance, is it one-to-one? Okay? So in other words, they're using this side for x's and this side for y's. And if it's one-to-one, nothing can repeat on either side. So, okay, because it first of all has to be a function, which means none of their x's can repeat. And then it has to be one-to-one, which means none of the y's can repeat. So if you look at here, A, B, C, D, E, F, we're good there, right? They're all different cities. Now let's look at the distances. 1432, 763, 1095, 598, 1093, 1226. They're all different as well, right? So it doesn't matter which direction you're going, all of the values are different, right? So that indicates that we have a one-to-one function. Now, what if this number had been 763 again? Do you notice that it occurs twice in my y list? That cannot happen if it's going to be a function. A one-to-one function, I'm sorry. Okay? So, let's answer our question. Yes, this is a function, and it is indeed one-to-one. Okay? So it's fairly easy just to make a list of your x's and y's and be able to see if something is not only a function, but is also one-to-one. Now there is also another test for one-to-one functions. And that's if you have the graph. Remember, we can test to see that something is a function by using the vertical line test. We can test one-to-one by using the horizontal line test. Which is exactly like the vertical line test, except that now we're drawing horizontal lines. So let's say that we have this shape. You can draw vertical lines all through this thing and hit it more than one time. Therefore, this is not a one-to-one function, even though it is indeed a function. Okay? Now, you've got to remember, it can't be a one-to-one function unless it's also first a function. Okay? So you've got to make sure that it is indeed a function before you decide to see if it's one-to-one. Okay? So let's look at our next question. So here, study found the trans fat content in fast food products varied widely. Here's our thing. So what we want to do is, first of all, remember that this side is our x's, this side's our y's, and what we have to have is no repetition on either side. So first of all, we'll check our x's to see if it's a function. A to 18, B, C, D, E, F, right? And each one of those leads to they're all different, so they have to lead to one y value. Okay? So now, we need to check over here. 18, 10, 11, 6, 2, 3. Was there any repetition on this side? No. Therefore, it is, first of all, it is a function, which is very important, and it is one-to-one. So, let's make sure. There we go. So it's very simple. It mathematically is a very easy concept, but it leads to other concepts. So we've got to make sure that we know how to utilize it. Remember, everything that's easy, we don't take seriously. So really work to understand these, otherwise you're going to get in trouble later. Okay, this time they're going to give us a graph, and they want to know, is it a function and is it one-to-one? Now they don't ask you, is it a function, but it has to be in order to be able to be one-to-one function. So before we decide that it's one-to-one, always make sure it's first a function. And if you look at this, you can draw vertical lines all day long. You're never going to hit it more than one time. So yes, indeed, this thing is a function. So now what we'll do is we'll use the horizontal line test to see if it's one-to-one. And you'll see that no horizontal line you can draw, no matter where it is, from top to bottom, is going to hit that line more than one time. So that tells us that yes, indeed, this is a one-to-one function. Okay, so click on yes, check it, and there you go. So all of these so far have been one-to-one functions. That is not always going to be the case, by the way. Let's look at the next one. Determine whether the function graphed is a one-to-one function. Okay, so the first thing we need to know is it indeed a function? Don't forget that step, because that's going to cause you trouble later if you don't. So you can draw vertical lines all day long, and it's never going to hit it more than once. Even though it looks like it kind of does here, it doesn't. That thing never goes straight. Remember, they're always kind of flaying out a little bit. Okay, so it is a function. Now let's see by the vertical line test, the horizontal line test, to see if it is one-to-one. And yes, indeed, there's no place you can draw a horizontal line and hit it more than one time, which tells us that yes, it is a function. And we can look at the choice. Every horizontal line intersects the graph at exactly 1 point. Oops. Wait a minute, hold on. They like a different answer than that. That is exactly true at exactly 1 point. Ugh, sometimes I really worry about myself. Look at what happens. I'm so looking for one-to-one functions. This is not one-to-one. Look what's happening. It's hitting twice there. It's hitting twice there. It's hitting twice there. It's hitting twice everywhere. Oy. So it is not one-to-one. You see the importance of paying attention. So it is a function, but it's not one-to-one because we're whacking that thing up twice every horizontal line we draw. So don't listen to me first. Listen to me when I'm right. So It is not one-to-one. Okay? So there's a horizontal line that intersects the graph at more than one point. Sometimes. Okay. One of these days I'll make sure. Okay, now what we have is we want to determine if this function is one-to-one. So many times, if you remember those parent graphs, then you'll know if a function is going to be one-to-one just from knowing what the graph is going to look like. Okay? So for example, if you look at this particular graph, you don't see any exponents, do you? It's y equals x minus 9. Well, I don't know what that line is doing, but I know from experience that that is a linear equation, which is a straight line. And there is no way that you can hit a straight line more than once, no matter if you're doing vertical or horizontal, unless it is a horizontal line. Okay? And we know if it has anything added to or subtracted from it, it can't be a horizontal line. Now, if you wanted to graph this, then you could, using any of the methods that we've looked at so far. Let's just erase these. But if you know what the graph looks like, then it's easy to tell if it's a function or if it's one-to-one. All right? So this is crossing through -9, and it goes up 1 over 1, so this line looks something like that. Okay? If that's -9, the y-intercept. So there's no way that this thing is not one-to-one, because you couldn't hit it with a vertical line, you couldn't hit it more than once with a horizontal line either. So yes, this is the graph of a function. And you're going to find that unless it's that special case where it's a horizontal line, every linear equation other than that is one-to-one. Okay? Go to the next one. Determine whether the function defined is one-to-one. All right, here we have our graph. And now they're going to give you lots of different ways of determining whether these functions are indeed one-to-one. I'm going to tell you that sometimes you have to use their value just to be able to check it. But if you look at this thing and think about the parent graph, remember the graph of any square root function. Do you remember what that looks like? If it's a square root function, remember that's the one that's shaped like a V? Well, I can hit V all day long with 2 lines, right? So I already know it's not one-to-one, even though it is indeed a function. But if you'll look at your answers, that's not one of the ways they choose it. It's either yes or no because of the things that they have for you. So here, we know that it's not a function because the graph is not the graph of it's not one-to-one because the graph is not one-to-one. But we have to answer their way, and they're going to make us do a little math in order to answer this. Okay? And this is another way of telling you if it is indeed one-to-one. If you choose 2 different values and come up with the same answer, well, that can't happen, right? That's 2 different x values leading to the same y value. So for this one, what they want you to do is they want you to plug in the numbers and do the math. So first we'll do the +2 here. So all I did was wherever there's an x, I put in a +2. 2 squared is 4. 31 minus 4 gives us the square root of 27. Now square root of 27 is not a perfect square, so we'll just leave it like that. Now what we'll do is we'll check the other value and see if it gives us the same answer. Don't worry about changing that into a decimal or anything. You could. -2 squared is 4. Square root of 31 minus 4 is 27. I got exactly the same answer twice. Well, remember, I can't have 2 values that lead to the same y value. Okay? So that's another way to define that this thing is not one-to-one. Okay? Now, I personally think it's easier to tell from the graph, but they want you to recognize that you can prove it mathematically as well. Okay? And they're forcing you to do that because they want the value in there. All right? So you're going to have to type in the value. So it's no, because two x values, 2 and negative 2, they'll give you the values they want you to use, lead to the same y value. Okay, so just plug in the numbers that they give you and see, and you can double check it. It's kind of another way to be able to tell. Okay. But again, if you can tell the parent graph, that's the easiest way. Now, the next one. Determine whether the function is one-to-one. So the function is f of x equals 3x squared minus 9. And if you remember 3x cubed, that graph looks like this. Now, it shifted up and down. Who cares? We're just worried about the shape of the graph. And if you look at the shape of the graph, remember horizontal lines all day long because it is indeed a function. And look what else. Vertical lines. I said those backwards. Vertical lines all day long because it's a function. Horizontal lines all day long because it's also one-to-one. So we know that this is indeed the graph of a function. Okay? Now, remember some of those cube ones did really deep dips. So we also have to be able to prove these kinds of things mathematically. Now this one doesn't because we know it's a really simple one, 3x squared minus 9. We can graph that really easily. So they want us to choose some values to choose it because each x value corresponds to only one f of x value, and each f of x value corresponds to only one x value. Okay? Now, so what they want you to do is see that the two things would come out equal. If you use two different numbers, they could come out equally. Okay? And so what they do is they find f of a and f of b. These two things have to be equal if it's going to be a one-to-one function. Okay? And then, so that means plug in a, plug in b, and the two things have to be equal. So f of a would be 3 times a cubed minus 9. You see what I'm doing is all I'm doing is replacing the x with the two, with a and b, and then work it out. So it gives us 3a to the third minus 9 should equal 3b to the third minus 9. Add 9 to both sides to get the a by itself. Gives you 3a cubed equals 3b cubed. But you can already see that these two sides are identical, aren't they? And this is identical to this, except for the letter. So that means that a does indeed equal b, so we're in good shape. And you could follow it all the way out, and you would end up with a equals b if you divide by 3, etc. My advice, know the graph. It's a lot easier. Okay? Some of them you'll have to do mathematically, and we'll talk about that as we go. But if you know the parent graph, you're in much better shape. Okay? So yes, it is a function. And it is one-to-one. Okay. Decide whether the function is one-to-one. Okay. Well, I'm going to tell you that this function is not one-to-one right off the bat. And you can tell because of that exponent right there. This is the graph of an x squared, which is always a parabola. Now, is it in that spot? No way. I don't know where it is. It does have a downward shift of -5, but it also has a horizontal shift of 3, so it can't be there. But you know that it's an upward opening parabola, which is a function. All right, vertical lines all day long, so it is a function. But oops, sorry. Look what happens when you start drawing horizontal lines. You start hitting it at more than one point. So knowing those parent graphs has been a huge help to us, and it's a huge help to us now. So this is not a one-to-one function because of the fact that you can hit it more than because of the horizontal line test, right? So without having to do it mathematically, we can think graphically and make our lives a lot easier. Okay. Now that is if you can choose the graph, the correct graph. Let's look at the next one. Okay. Here we want to determine whether the given functions are inverses. So we need to talk a little bit more about inverses. They are incredibly easy. All you need to do to find the inverse is simply reverse every x and y value. But it must be a function. Sometimes they'll mess with you there. And it must be one-to-one function. So you still don't get away with not being able to not having to see if it's a one-to-one function, and indeed if it's a function only. But for every function, every one-to-one function has an inverse, and all you have to do is simply reverse the x and y values. So the mathematics, again, is very easy. The understanding of what it is you're looking at is going to be your difficulty, if indeed you have any difficulty here. Okay, so let's look at this one and see if it, first of all, is indeed a function. So here's our original. We'll look at that. -3 leads to 3, 1 to 2, -5, 0 to 1. So yes, it is a function, right? Do I have any repetition here? No. So therefore, it is 1-to-1. Okay? So now all I have to do is see if, so I didn't have any repetition in my x's, didn't have any repetition in my y's. Pretty easy if you're given all these values in a chart. So now what we'll do is go over here to this side of it and see, did they reverse everything exactly? So here we have 3, -3. That is exactly the reverse of this. They have to get the right sign, the right numbers, everything. So this one, -2, 1. Yep, that checks. -7, -5. Yep. -1, 0. Yes. So are they inverses of each other? Yes. Okay, because first, they are indeed functions. They are indeed one-to-one functions, and then they just reversed everything. Okay. And if you multiply those together, you get a 1. And that's the definition of inverses. Hopefully they won't ever make you do that, but there you go. You know that it would happen. So let's look. Determine whether the given functions are inverses. So what we need to do first is we need to determine if it's a function. So let's write it out. It says f equals 1, 6, 2, 6, 3, 6, and right away I'm in trouble. 1 leading to 6, 2 leading to 6, 3 leading to 6. That can't happen. This is not a function. Remember, every x value has to lead to a unique y value. So I don't care if they say they're inverses or not. If it's not a function, it's not going to have an inverse. So this one is not going to happen. All right? So you see how important it is to understand if something is a function, because they can look as if they're inverses, but they're not. This one doesn't even look like it anyway, but still. You have to check to see if it's a function first. And indeed a one-to-one function. Use the definition of inverses to determine whether f and g are inverses. Okay? So this time what they're going to do is they're going to give you two different functions, and they're giving them to you as equations. So what we have to do is determine if these two things are indeed inverses of each other, and this time we're going to have to do it mathematically. Now you could, if you wanted to, simply make a chart of x and y values and then see if the x and y values are reversed. Right? Now we know these are functions because they're both linear. Right? The x's are in the top, so that means they're not discontinuous, anything weird. So that we know they're both functions. So we could literally choose some x values and then let's do some easier x values and then see if we got exactly the same, the opposite numbers on the other side. Okay? So let's do that and see what happens. So let's first choose 0. We like 0 because in the first one, f of 0 is going to be 3 times 0 minus 15. In other words, the 3 times 0 is going to go away, gives you minus 15. Now let's see what happens on the other side and see if we put y equals 0, if that gives us the same thing. Be careful, don't put it as x. That won't work. All right? So first of all, we want to get rid of this 3 by multiplying everything by 3. Remember, that says divide by 3. The opposite of divide by 3 is multiply by 3. 3 times 0 is 0. These 3's will divide away, gives you x, and that gives you plus 15. All right? So we're happy with that so far. Subtract 15 from both sides to get the x by itself, and you get negative 15 equals x. So it's negative 15, 0. So these two are inverses, aren't they? And unless you really screw up the mathematics, if you get one that works, then the others are going to work too. So this is telling us that these two things are indeed inverses of each other. Okay, so let's click on yes and check that just to make sure I haven't messed it up. There you go. Now you could do more numbers if you want to on that chart just to be sure, but you don't have to. Okay? Just be very careful that you know one of them is an x, so you're going to put in place of x. The other one's a y, you're going to put in place of y. Otherwise, it won't work. Okay? So be very careful where you place the numbers when you're doing the mathematics. Okay? And if you can use 0, that's always the best point you possibly choose. It's the easiest one. Of course, remember that 0 doesn't exist on every graph, but it's going to on every linear graph unless it's a horizontal line. Okay, here we go. Got two more functions. Let's take a look at them. So let's see what happens when we choose an x and a y for each function. Okay, so let's choose x equals 0 and y equals 0. Right? They have to be the same number in order for them to be inverses. So first we'll find f of 0 equals negative 2x plus 10. Okay. So that gives us 0. Negative 2 times 0 plus 10. Okay. That's 0, isn't it? So 1. That gives us 0 plus 10, which gives us 10. So it should be 0, 10. So that means I should be able to do the same exact thing, replacing that g of x right? With 0 replacing, because remember, because g of x is the same thing as saying y. So we're using y here, but that's the same as g of x. We should be able to do the same thing and get exactly the same value that we got for x on the other side. So let's look and see if that happens. So 0 should equal negative 1/2 x minus 10. And you could reverse these so that you're not always working with the fraction one. This one would be easier to put the 0 here and work it out and get rid of the fraction quite easily. But it's not hard to get rid of a fraction of 2. Just multiply everything by 2. Watch those signs. 2 times 0 is 0. These 2's will divide away, so that gives me negative 1x. 2 times negative 10 is negative 20, right? Negative 1x is the same as just plain old negative x. Get the x by itself by adding 20 to both sides. Gives us 20 equals negative x. Divide by negative to get that x to become positive. You rarely divide it by negative 1, which gives me x equals negative 20. So, are these two things the same? No. So what that's telling us is that these two things are not inverses because they're not giving us the same value, just reversed, which is what an inverse does. Okay? So all you have to do is pick an x and then use it for x, then use the same x value for the y and see if it gives you the exact same point reversed, right? Because inverse just means reverse them pretty much. Okay? Let's see what they do on the next one. Okay. Now, these, you have to be a little more careful because they're going to give you a little more information that changes things somewhat. Okay? And it's right there, the domain. So in other words, these graphs are not going to have the whole entire graph. Okay? For example, this first one says f of x squared plus 9. Well, if you graphed x squared plus 9, okay, that means it's got vertical shift of 9, so that means the vertex is up here at 9, and you get this business, right? But look at the domain. It says this thing only exists from 0 to positive infinity. So in other words, it doesn't exist over here. Now if you look at this, it is a function because it passes the vertical line test, and it's also a one-to-one function because you can do this business. You see that? Because they've limited the domain, it's cut the parabola in half, so you only have half of it, which means it is indeed a function. Now, so we can do the same kind of idea with using two numbers to be able to find if they work out in a chart, right? And reverse them and still do the math, but you've got to make sure that those numbers fall within your domain. Okay? So let's try this business first. Okay? Because see, normally an x squared wouldn't be a one-to-one function, but because they're giving you a domain, that's just telling you that it is. Now, also the same thing with the other one. A square root would be like this, but they're telling you that this one starts at positive 9. That's absolute value. I'm such a dork. A square root would be like this. So they're telling you it starts at positive 9. So we're still talking about a function, and it is one-to-one. So we're in good shape there. So let's go ahead and see if this test works for us. Okay. So Okay, so let's make our charts. An x value and a y value, x value and a y value. Gonna leave a little more room. So now before I was choosing 0, and I did that because 0 is such an easy number to work with. But if you look at the domain of this, you can't choose 0. 0 is not in that domain. From 9 to positive infinity is not including 0. So we'll just choose 9. Or you could choose 10. Doesn't really matter. How about 10? Because 10 is really easy. Right? So let's do the math. So the first one, we're going to find f of 10. That should be 10 squared plus 9, which gives us 100 plus 9, which is 109. Everything good? Okay. So that means there is the value of one value on our function from our first function. This time we're going to use not x equals 10 but y equals 10. So we're going to replace the g of x with 10. Right? Remember, because g of x is the same as saying y. Okay? So we put in our y. We've got to get rid of this radical. Remember that the opposite of a square root is a square. If you square something, it gets rid of the square root. But you've got to do that on both sides. Remember, whatever you do to one side, you have to do to the other. So 10 squared is 100. The square and the square root will simply eliminate each other, which gives you x minus 9. Now it's just a simple linear equation. We need to get that x by itself by adding 9 to both sides, which gives us 109 equals x. So our x value is 109. Are these indeed inverses? Yeah, you got the same thing but reversed. So they are indeed inverses. Picking some numbers in the domain and then just doing the math is probably the easiest way you can do these. Now, you can follow their convoluted mathematical proof way of doing it if you want to, but I don't see any reason to, because your calculator can do most of this math. So anyway, it's up to you. Make it as hard on yourself as you want to. So are they inverses? Yes, indeed they are. Okay, let's see what's next. We only have 2 more to go. You'll be happy to know. Maybe we'll get lucky and they just keep doing the same thing over and over. If the function defined by the following is 1 to 1, find its inverse. Okay, they've made it easier on us. They just give us a list of values. So let's first begin by looking at that list of values to be sure that this thing is indeed a function, and it is indeed 1 to 1. So -4 leads to 6, 1 leads to 3, 5. So there's no repetition in our x's. There's no repetition in our y's. So yes, it is a function, and yes, it is 1 to 1. Okay? Right? Because all we did was look at them. Now what we need to do to find the inverse is simply reverse them. 6, -4, 3, +1, 8, +5. In braces, which they've actually already included. All you have to do is type in the ordered pairs. Well, you know that it would take me 20 minutes to type that in. So I'm not going to do that. What I'm going to do is I'm just going to click on Show Completed Problem. No, better not, because it always changes your numbers. So let me just type this in. I hate it when I have to do things. Okay, so, whoops. Let's see right away. So my ordered pairs are 6, -4, 6, comma, -4, close parentheses, comma, open parentheses. The next one is 3, 1, 3, 1, close parentheses. Make sure you're separating your answers with a comma or they'll count it wrong. And then finally, the last one is going to be 8, 5. 8, comma 5 in parentheses. They've already got the braces there, so we should be good there. And if I'm wrong on this, I'm going to be so sad. There we go. All right, so they went back to the easy kind where all you have to do is determine, is it a function, is it one-to-one, and then just reverse all the points. So no math involved there at all. Just looking at things. And now 15 is the function, all right, defined by the following one-to-one, find its inverse. So the first thing we want to do is look at the function itself to make sure it is a function. 5 leads to 4, 3 leads to 3, 2 leads to 7, and 6 leads to 3. So we're good with function, right? This thing is a function because there's no repetition in your x's, right? Now what we need to do is see if it's one-to-one, and we do that to see if there's any repetition in your y's. 4, 3, 7, 3. And there's our issue. We do have repetition in the y's, so this thing, although it is a function, it is not one-to-one. And if that's the case, it cannot have an inverse, right? Remember we said that the only way it can have an inverse is if it's a one-to-one function. So this function is not one-to-one, therefore you will not have an inverse. Okay? So actually they went to the last two, made it pretty easy on you. All right, there you go. So there you, for one-to-one functions, make sure that you understand those. Mathematically they're very easy. So we'll start off with something kind of quick and easy there, and then we're going to move forward. Now next time we meet we're going to talk about the laws of some things about exponents. So if you want to look at the laws of exponents somewhere, it wouldn't be a bad thing, but of course we'll cover it quite completely. Thanks so much. Bye.